Hello, in this demo we'll see how we can implement a simple talk application using Windows Communication Foundation. Basically, with other frameworks we have to expose a service on the server side and one on the client side, and the client will have to register with the server so that the server would know where to contact the client back to deliver a message. So what we intend to do is to do application level broadcast. We will have a server, all the clients will register with the server, and when a client is sending a message, the server will broadcast the message to all the registered clients. With Windows Communication Foundation, this can be achieved easily because it supports duplex channels. So on the same channel, the server can also contact the client back. We started actually by creating a DLL here. This is something that's going to be shared between client and the server. So in this class library, we define first the server contract. So on the server side, we will have a component which will implement the following methods. Sorry. It will allow the client to subscribe, to unsubscribe, and to send a message to all the subscribed clients. Because those messages are delivered in one way, we don't expect anything from the server. The methods are returning void. I also configure this to be one-way method. Then we define the client contract. So the server should notify the client by calling a method on a client component. Therefore, we have also to define a contract with this method. So when a client will send a message to the server will then contact back the clients calling the onReceive methods of each client. As you may see here, we are using Windows Communication Foundation, so we added a reference to the System Service Model DLL, which is from Global Assembly Cache of .NET. And of course, we need to annotate our interfaces with the appropriate attributes. This should be the service contract, and those would be the operation contracts. These annotations are fulfilling two roles. First of all, based on this, the server will generate the WSDL, so the definition of the contract will be using this to know what methods to include. And secondly, this is a security feature. Basically, the channel that's being invoked by the client can execute any method the client would request, but having these annotations would control what methods to be exposed and what methods we allow to be executed by the client request. So after annotating both the server and the client contract, we have to link those two together. So we specify the attribute, the property callback contract on the service contract, telling that the server, which will contain a component implementing this contract, may contact back on the same channel the client, calling methods from this contract. If we try to contact the client with other interface and other contracts, it will raise an exception, it will throw an exception at runtime. So we have to specify the callback contract. Now, having this defined here, I created a console application, which would be the server, and the server would have to know the contract, so would have to have a reference to the project common and also to the system service model, because we are using Windows Communication Foundation framework to implement and publish the service. So I started by implementing the server service. This should implement the iService server service contract, and it will have to keep a list with all the clients. Therefore, we need to have a list of the clients, and this should be a static field. Of course, if we publish the service as a singleton, we will have only one instance, so all the clients will talk to that instance. But we have to implement this regardless of how this will be published. So I have a static field to list all the clients. When subscribing, I created a property just to create a proxy to invoke the iService service back. So instead of having to implement a particular class, we are free to call an operation context. So imagine that the channel that will receive the call to execute a method of this service will set a singleton dispatcher. So we have a class operation context which has a current property, and with this operation context we can create a proxy to call the client contract back. So we get a client channel with this call, and here our service has to implement an interface which is linked by the callback contract to this contract. Otherwise it will not allow us to obtain a proxy to call this contract back. Now, having this property, when we subscribe, we need to have exclusive access on the client's list, because several threads will work with this on the same time, and we just add our proxy to the list of clients. When we unsubscribe, we remove the proxy, but this time a new instance of the proxy will be created. However, because of the way the equals it's overridden in this class, when we unsubscribe, we will remove an object which has a different address but has the same content as the previous one, so we are able to remove the client added previously. Now, when we have to deliver a message to all the subscribed clients, we keep the lock on the clients, we iterate on the list of the clients, and then we call the contact client back. So this will use the same channel to deliver a push notification to the client. Now, after implementing the service, we need to publish it, and we need to start a channel listening for incoming requests for that service. This is done very easy here by creating a service host, which is a class from the service model framework. We can publish either a type of a service, which in this case means that each client will have its own instance of the service when calling the service methods, or we can publish only one instance as a singleton for all the clients. In my case, I chose to use the type because we might need to have additional information for each client on the server side. Now it's not the case, but if we like to change this and turn into a chat, we will have to do that. But because of the fact that we have a list of connections as a static field, we don't care whether or not this will be a singleton. After creating the host, we open it and we just wait for additional commands, like the only command we implement is exit to stop the client. We even avoid to call the close method directly, because this is implementing iDisposable and it's gonna be translated into a try catch finally, and in the finally statement we will have a close call on the host. So this is how we publish the service. As you may see, we have no information about the infrastructure of publishing the service. We only have described here that we need to publish a service of this type. It is better, instead of doing this programmatically by calling the methods to publish the service, it's better to use a configuration file. In case the configuration will have to change, the deployment will have to change, we will not need to recompile the class. So we have an application configuration file in the project, and in here we define the configuration. We added the configuration for system service model, and we published a new service. The name of the service has to match the name of the class. So this is the package, the namespace in which the class has been defined, and this is the name of the class we are exposing. When we create a host on this type, we have to have an infrastructure published that's gonna have the same name for the service. A service may have multiple endpoints. An endpoint is it is identified by an ABC set of attributes. The A stands for address, and this is where the service is located. Because we are using a proprietary .NET framework on top of TCP and not over HTTP, we are using a special schema net.tcp for that. There are several built-in bindings, which stands for how to connect and consume the service, and we are using the default one for this schema, which is net.tcp binding. And then you have to specify the contract, basically what the service does. So this is the interface that we expose. Because a class may implement several interfaces, it may have different endpoints, one for each interface, but it can also contain several endpoints for the same interface. Like we are exposing via NetTCP the interface for .NET clients, but we might expose via standard HTTP for other platforms if we have clients implemented in other languages. Now, after creating the server, we need to create the client. So I added here a Windows Forms application, which is a simple UI. It will contain a simple UI to call the service on the client on the server side. I mean, to have a client for the service. So I design a simple interface here, which has a list and a text box, and we will use the text box to enter some data. Now, I added two references, one to the common project, which is a DLL, and the other to the Windows Communication Framework that we are using, namely the DLL called system.service model. Now, I created a client service, and this client service has to implement the iServer service, service interface. But it actually, we should change this. It is not necessary that our proxy is implementing the service interface, because as you may see, we are going to hide the details of how we consume the service. So let me just update this and make it simpler. I don't need to have a public method subscribe, but rather I call the public method when I create the object. So let's just turn this into private. Okay. And I will make the unsubscribe method private as well. Makes no sense to expose that publicly if I control when they are invoked. So the only thing I need to do in order to create a proxy, I have to extend a particular class of the framework, either client base or in my case duplex client base. Client base is for a channel which is used for request response invocations or one way, but not for notifications from the server. So the client will be able to call a service, to call a method remotely with a client base, but it will not be able to receive notifications from the server. In my case, I need to do that. So I extend another class of the framework, which is called duplex client base. I have to specify which interface I like to consume. So this is going to be the contract of the component on the server side. And in my case, I don't need to implement this interface because I will not consume directly all the methods of the interface. Rather, I like to be able to call only the send method publicly. The other will be called depending on how the object gets created. One thing to notice here is that I cannot create a service, a proxy like this, which is going to be handling the incoming request from the server as well, if I don't provide an object like an instance context that's going to be the target on which we invoke the notification from the server. So imagine that when the server will call the client back on this channel, the call should be dispatched to this instance. So I need to have here an implementer of the client contract. This is not the implementer itself, although it is the one invoked by the server, but rather it will dispatch the call on this object. So by receiving an argument of the client service contract type, I create a target with this argument, and then I implement the logic of subscribing to the server. When I create this object, I like to subscribe automatically, and when this object gets deleted, I like to unsubscribe. What's interesting here is that because I'm extending a client base, either a duplex or a simple client base, on top of an interface, that's going to be the contract I like to call, .NET will generate a class at runtime that will actually implement this interface. And when I'm implementing the interface, I receive a property that's inherited from the class client base or duplex client base. The name of the property is channel, and the type of the property is exactly the type of the contract that I use here. So basically, when I extend the class, a new class will be generated at runtime implementing this, and I will receive here an instance of that type. With this, I can then dispatch the call of all the methods from this contract. What's going to happen here is that a channel will be open to the server. It's going to be a TCP connection, and depending on the binding, it may use HTTP with SOAP attachments over that TCP connection, or it may use directly the TCP connection with binary encoded XML or whatever kind of binding I have to communicate and consume the service. So this is basically how I can implement a proxy. Now all I have to do is to consume this with my UI, and I'm gonna show you the code. So I created, first of all, my class should implement the client contract. And when I receive a message from the server side, I just add the message to the items collection of the list box to display it, just to display it on the UI. One thing to notice here is that I don't have to invoke the UI thread to do this by itself. Normally, this will be executed on a background thread. It's not going to be the thread of the UI. So normally what I have to do is take this control and invoke a method just to say to the UI thread, please execute this code by yourself. This is not necessary with the Windows Communication Foundation notifications because the framework does it by itself. Now, I have defined here a client service object, and when I load the form, I then create an object of this type telling that the implementer of the client service would be this form. Now, when I type something in the text box and I release the key, I check if the key released was enter. So the idea is that I like to type something and press enter, then when I release the key, this should go to the server. And also check that the text in the text box contains something which is different than blank spaces. If so, I take what the user entered in the text box and I send it to the server. I also erase the text box, the text in the text box, so the user will continue entering some new text. And that's all. In order to discover the service, this is done automatically by the configuration file. So in the application configuration file of the client, I also configure the system service model namespace. Here I define a client, which is a simple endpoint. The arguments of the endpoint will have to match the arguments defined on the server side, including the address of the service, the binding to communicate with the service, and the contract exposed here. Now, with all this ready, I'll just build it again, and I'm gonna test my solution. So I will start a startup server, the server project, and I will start it without debugging, so that you will just see the execution. Okay, and now the server is started. It's opening the port and it's asking me to allow this. Okay, let's just allow this, and it says that the service is started, and I may type exit to stop it. Now let's just set as startup project the client project and fire up a new client. Okay, so this is my first client. And then start a new one. They are registered with the server and they can talk to each other. So let me just display both clients. And the first one is saying, can you read me? Can you read me? Okay. And as you may see, the message gets delivered to the second client as well. Yes, I can. Okay, so basically with this approach we can easily have a service on the server side which is exposed as an XML web service, and the service on the client side which is attached to the proxy that's executing methods to the server. So we can receive notifications from the server and handle the notifications back with the client proxy. So that's all. Thanks.